Hi, in this example, I'm going to explain how to find local extrema with first derivative test. This is the expression we are given, fx equals 3x exponent 5 minus 20x cubed. Step 1 would be you take derivative of this expression. This is how it works. Here x has exponent 5, multiplied by 3. 5 multiplied by 3 will be 15. That is how I got this 15. Then 5 minus 1 is 4. So 4 will be the exponent of this x with 15. Repeat the process here. Multiply 3 by 20, which is 60. So that is how I got this 60. And 1 less than 3 is 2. So the exponent of this x is going to be 2. Step 2. Now take this expression, the derivative of fx, write it equal to 0. Then we will focus on factoring this expression. So in this case, what we can do, we can factor out 15x squared. So when you factor out 15x squared out of 15x exponent 4, x squared will be left over. When you factor out 15x squared out of 60x squared, minus 4 will be left over. Put brackets around them, equal to 0. Then x squared minus 4 can be factored further. It is a difference of squares. I have explained it in another video. How would you factor an expression like this? You can watch that if you do not remember this. X squared minus 4 will be factored into x minus 2 times x plus 2. 15x squared is sitting outside the brackets there. Now, these 4 terms are multiplying to 0. This, and that, they're multiplying to 0, which means at least one of them is 0. 15 cannot be 0. X squared can be 0, so I wrote x squared equals 0. X minus 2 can be equal to 0, so I wrote x minus 2 equal to 0. X plus 2 could be 0, so I wrote x plus 2 equal to 0. If x squared is 0, x has to be 0, because x squared means x multiplied by itself equal to 0, so x has to be 0. If x minus 2 equals to 0, it means that x has to be 2, because 2 minus 2 will give us 0. If x plus 2 is 0, it means x should be negative 2, because negative 2 plus 2 will give us 0. Okay, now these values we just found are called critical points. In the next step, step number 3, we're going to plot them on a number line. So there is 0 here, I plotted 0. And then 2, positive 2 is here. Then negative 2 is here. So plot the critical points. Then what we need to do, we need to pick a value to the left side of this critical point. I picked negative 3. You can pick negative 4, negative 5, negative 10. Does not matter, as long as it is on the left side of negative 3. Then pick a value between negative 2 and 0. I picked negative 1. You can pick a different value if you like, 2. Similarly, between 0 and 2, I picked positive 1. And on the right side of 2, I picked positive 3. Now take these values I have written in blue, and we're going to plug them in f dash x. We're going to start with negative 3. We're going to go f dash negative 3, which means we're going to replace x by negative 3 in this expression. So we will have 15 negative 3 inside brackets exponent 4. 15 negative 3 inside brackets exponent 4. Then we have in this expression negative 60 x squared. So we're going to have negative 60 inside brackets negative 3 squared, because we are replacing x by negative 3. Now let's do the calculations. Negative 3 brackets exponent 4 is going to be positive 81, because it means a negative 3 is multiplying itself 4 times. When you multiply a negative number 4 times, you're going to end up having a positive number. Similarly here, negative 3 squared is going to give you positive 9. Now multiply 15 by 81, you will get this number. Then multiply 60 by 9, you'll get 540. Now minus those two, you will get 675, which is a positive number. The value does not matter, but the sign of this number does matter. So I wrote positive and I wrote a positive sign as well. Now pick the next value for x, negative 1. So you go f dash negative 1. Now replace x by negative 1 everywhere in this expression. Because I do not have enough space here and I want to keep this video short, so I'm not explaining the steps. I'm just writing what you will get when you replace x by negative 1 in this expression. You will get negative 45, which is a negative number. I wrote the negative sign too. Similarly, when you replace x by 1, f dash 1 is going to be negative 45, again, which is a negative number, and f dash 3 is going to be positive 675. So that is, I wrote positive. Now, again, in step 5, we're going to plot the critical points we had got from here, we got from there on a number line. So 0 is here, negative 2 is here, positive 2 is here. Now we're going to use these signs we just found out. We found out when f dash negative 3 is positive, so we're going to put a positive on the left side of negative 2. Similarly, when we picked a number between negative 2 and 0, when we picked negative 1, we got a negative sign, so I put a negative sign. Similarly, for positive 1, we got a negative sign, so put a negative sign here. For f of 3, we got a positive sign, so I put a positive. Now, if you got a positive sign, it means your graph will be increasing in that interval. So that means that on this side of negative 2, the graph is just increasing like that. So you can draw a line curve like this, make it increasing curve, but stop at negative 2. You can see that between negative 2 and 0, there is a minus sign, negative sign. It means the graph will be decreasing. So now it will be decreasing like that. Stop at 0. Now look for the sign between 0 and 2, which is a negative again. So it means it's going to keep decreasing. Now stop at 2. Now on this side of 2, we have positive sign. It means starting from 2, now graph will start increasing like that. So now you can see that, that point is the highest point of this graph, maxima. So we call it maxima. And this is the minimum point. So we have maximum. We have maxima at x equals 2 because x is x equals a negative 2 because x is a negative 2 here, and the minimum point is at x equals a positive 2, which is here. Okay, now step 6. In step 6, we will try to find out what are the y values of this and that point. So what we will do, we will replace x by negative 2 in the original expression, not in the f dash x, but in the original expression. So we're going to replace x by 2. So we're going to go f of 2 equals 3 times f of, let's replace first x by negative 2. So f of negative 2 equals 3 inside brackets. There will be negative 2 inside brackets exponent 4. So that's what I wrote here. Then next we have is negative 20. I wrote negative 20. And then we have x cubed here. So because we are replacing x by negative 2, so we will have negative 2 inside brackets, then a cube there. Now, in the next step, I wrote f of negative 2 again, equal sign, keep 3 there. Negative 2 exponent 5 is going to be negative 32. Because we are multiplying a negative number 5 times, So you will end up odd number of times, so you will end up having a negative number. So negative 2 exponent 5 is going to give you negative 32. Similarly, negative 2 exponent 3 is going to give you negative 8. Now in the next step, multiply 3 by negative 32, which will give you negative 96. And then negative 20 times negative 8 is going to give you positive 160. When this is negative, this is positive, so take this away from this, you will have 64. So therefore, maxima is negative 2 and 64, which means here the value of this point, x value of this point is negative 2, and the y value of this point is 64. Similarly, now replace x by positive 2 in this expression. I haven't done the calculations. You please do them. You will see you will get to negative 64. So which means that this point's x value is at positive 2, y value is at negative 64. So that is how you find minima and maxima using first derivative test. Thank you.